Another thing Dalton's law tells us is that the total pressure, so I'm going to write that down before we read this problem, is equal to the sum of the partial pressures. So pressure of gas A plus pressure of gas B plus pressure of gas C plus so on and so on. So I'll put dot, 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 however many gases we have. So that's what the total pressure is equal to. So now let's read this problem. It says acetylene is produced in the laboratory when calcium carbide reacts with water. They give us a balanced equation, and they say a collected sample of acetylene has a total gas pressure of 738 torr at a volume of 523 milliliters. At that temperature, the gas, at 23 degrees C, the vapor pressure for water is 21 torr. How many grams of acetylene are collected? So, anytime we're doing a reaction with gases and water is involved, there's always going to be water vapor in the final product. So that's the type of problem we're looking at here. We have to take into account that partial pressure for water. Okay, so it says that the total pressure, so P total is equal to 738 torr. Right, that's equal to P total. The partial pressure of water, so I'm going to put pH2O, is equal to, at this temperature, 21 torr. We need to figure out what the pressure of acetylene is, right? So that we can figure out the grams. We can use PV equals nRT, right, to figure out the grams of acetylene that are collected. All right, so let's see. P total up here, P total is equal to the sum of all the partial pressures. So, if I'm interested in just the partial pressure of acetylene, let me get some more room to write here. Then that's going to equal, right, P total minus the pressure of the water, which is going to equal 738 torr minus the 21 torr from the water, right, which is going to be equal to 717 torr. So now I know the partial pressure of the acetylene, and I know that PV is equal to nRT, and I need to know the mass of the acetylene so that I can use moles to figure that out, right, once I know the molar mass of acetylene. So N is going to equal PV divided by RT, which is going to equal. All right, now remember the value we have for R has pressure in atmosphere, so let me go ahead and convert this 717 torr to atmosphere. 760 torr in 1 atmosphere. So 717 divided by 760. 0.943 atmospheres. All right, so 0.943 atmospheres times, remember our volume needs to be in liters, so I'm going to have to convert the 523, and so that's going to be 0.523 liters, divided by R, 0.0826 liters times atmospheres per moles times Kelvin, times our temperature in Kelvin, remember, so we got to say 273 plus 23, which gives us 296 Kelvin. Now let's check our units. I've got atmospheres canceling atmospheres. I've got liters canceling liters. Kelvin canceling Kelvin. Going to only be left with moles. And since moles is in the bottom of the bottom of a fraction, so it's in two bottoms, right? That means it's going to flip up to the top. And these units are going to be in moles. So let me do the math now. My 0.943 times 0.523, that's going to be divided by my R times my temperature. And I got 0.0202 moles of acetylene. But we're not done yet because they're asking for a mass, right? So if I've got 0.0202 moles of acetylene, I need to figure out the molar mass, right? So in 1 mole of acetylene, I've got to add up 2 carbons right? And 2 hydrogens, which is 26.04 grams of acetylene. That's how much is in 1 mole, right? And I got that from the periodic table data. So let's see, moles is going to cancel with moles. And I'm going to be left with 0.529 grams of acetylene.